The exoplanet I've picked is Kepler-105b. Kepler-105b is its default alias, but it has four other aliases: K00115.01, KSE957641b, KOI115b, and KOI115.01. It was discovered using the transit method. The transit method detects distant planets by measuring the minute dimming of a star as an orbiting planet passes between it and the Earth. Kepler-105b was discovered in 2013, referenced to NASA by Wang in 2014. The host star that Kepler-105b orbits is named Kepler-105. Kepler-105 has two exoplanets that orbit it, Kepler-105b and Kepler-105c, and also a third unidentified object known as KOI-115.03. All three of these objects are found to orbit far outside the habitable zone. The habitable zone is the range of orbits around a star within which a planetary surface can support liquid water given sufficient atmospheric pressure. These aspects of a planet are necessary for survival. This measurement is only an estimate, though, using the star's spectral type and its mass. Spectral type is a classification for stars based on the strength of their spectral lines or their surface temperature. The reason the measurement has to be an estimate is because of the solar system's distance away from the Milky Way, which is 524 parsec, or about 1,708 light years away. The distance to the stellar radius is 9 times the distance of Earth to its stellar radius. Stellar radius is the star's radius, so the distance to the stellar radius would be the distance to the radius of the star. Kepler-105 has a magnitude of 11.5. Magnitude is the ability to be seen by the human eye. This magnitude is just above the magnitude of the faintest star, which is 6.5 magnitude. Kepler-105's radius is 0.894 plus or minus 0.044, and its mass is 0.961 plus or minus 0.046. Those two measurements are relative to the Earth's sun. The temperature of Kepler-105 is 5,827 plus or minus 94 degrees Kelvin. This is very close to the Earth's sun at 5,800 degrees Kelvin. Its metallicity is negative 0.19 plus or minus 0.1, making it 0.178 less than the sun's metallicity, 0.012. Metallicity is used to describe the abundance of elements present in an object that are heavier than hydrogen or helium. The orbital period of Kepler-105b is 5.4122 Earth days, about 68 times shorter than Earth's orbital period. The ratio of the planet to the radius of the host is 0.028. Using this information, we can find that Kepler-105b's radius is 4.81 plus or minus 1.53 that of the Earth. Kepler-105b is a gas giant, most comparably to that of Neptune. It can be assumed that the planet has a high hydrogen and helium atmosphere due to the radius being over 1.5 times that of the Earth and because of its metallicity being negative, meaning a lack of elements that are not hydrogen and helium. Other properties cannot be found, such as density, mass, age, and luminosity. Information that can be found from its distance to its own sun is velocity. Using the equation v squared equals big G m divided by r, we can find velocity. Since we know the universal constant of gravity is 6.6 e negative 11, we can plug that in for G. We know that the mass of Kepler-105 is 0.61 plus or minus 0.046 solar masses, or 1.911 e to the 30th kilograms. We know the radius of Kepler-105b's orbit is 0.066 AU, or 9.873 e to the 9th meters. Solve and plug everything into the equation to get V equals 113,623.64 meters per second. This is more than 3 times faster than Earth's orbital velocity of 30,000 meters per second. There is a multitude of reasons that make this planet inhabitable. The first and most obvious is the distance. Since the planet is 1,708 light years away and have only achieved top speeds of 36,000 miles per hour in our fastest rocket, this speed it would take 19,178 years to reach the planet. Let's say we figure out how to travel at light speed, then we would face the problem that the atmosphere is mostly hydrogen and helium and a lack of oxygen. The Earth's atmosphere is mostly nitrogen and oxygen, two things that appear to be lacking in Kepler-105b's atmosphere. Third, It is a gas planet, not a rocky ocean planet like Earth. Lastly, water, which is needed for everything living to survive, is not present. Overall, human presence on Kepler-105b does not seem likely, at least in the near future, due mainly to distance. Although we cannot see Kepler-105b because of its magnitude, we know that it is there due to Kepler's Space Telescope. Alternate places for the Earth seem likely in our infinite universe of space, even if none have been discovered yet. In conclusion, even though Kepler-105b is inhabitable and looks to remain so in the near future, hopefully the Kepler Space Telescope or its replacement can discover a better option. Thank you.